Welcome everybody. My name is Anton Komrev. I am technical leader of Trusted Firmware M in ARM, and this is open technical forum for open discussion, any technical issues what we have or any ideas what we want to discuss in addition to the mailing list. A pleasure to announce that Renaissance have joined Trusted Firmware recently, so welcome to the TFM. And today in agenda we have 3 topics, and the first of them is attestation. Will be presented by Tamas. And for the second topic, if we need more time to prepare and can ask me to shift it for another session, maybe in 2 weeks from now. Then we will discuss any other items what we have in our mind or we have discussed recently in the mailing list. So let's start. So Tamas, are you ready?
Yes, I can take over. Okay, I'm sharing my screen. Okay, let me know. Can you see my screen?
Yes.
Yes. Yeah.
Yeah, okay. Hello, everybody. I'm Tamás from TFM team. I will give you a small talk about the attestation service and focusing on some profile small related activity which is enabling the Symmetric key based attestation tag authentication. Okay, first I will give you a short overview about the attestation service. I think many of you are already familiar with the attestation service because you are the user of TFM. So it will be just a quick overview. Then a few words about the internal structure of the actual attestation token. So what is CBOR and what is COSI, how they are composed, how the token is signed. And the main part of the presentation will focusing on to clarify the differences between the symmetric and asymmetric key-based token authentication, highlights its benefits and drawbacks. Okay, so first an introduction side, what is attestation? It's actually, it's like a getter function for the device. Server can ask the device to identify yourself, show your identity card. It sends a request to the device collects some device specific data, sign the data and send back to the server. Why is it needed? Because cloud service provider want to control which devices can access to their cloud, or you want to control what kind of services make available for certain devices, and you want to assess the device trustworthiness before sharing any sensitive data with that device. How does it work? It's very simple. It's a request response model. Yeah. This is next slide about the overview. In the middle of the picture, you can see the device when in the secure side running the attestation service. It expose an API towards the non-secure world, like other secure world services. Its API, it's very simple, just 2 function call. The device maker makes sure that a unique attestation key is provisioned to the device during the manufacturing process. And when this is done, some device-specific data must be recorded in a database, which database is available on the verifier side, which is somewhere in the remote cloud. When the server wants to establish connection with the device, it requests to share your attestation data. Device collect everything, send it back, sign the token, sign with the private part of the attestation key, which is available in the device. It's unique per device. On the verification side, the verifier can look up the corresponding public key, can validate the signature. The signature is ensuring the authenticity and the integrity of the token. And when this is done, then it can look into the token, parse the internal structure, and check one by one the available data items and comparing to the expected values, which software version is running on the device, what is the hardware version, and so on. Okay, this slide is about the attestation flow. On the right side, you have the validating entity, who is a remote party. He sends a request to the device. The only input parameter for the attestation service is called challenge. This challenge can be a random value sent by the server, sent by the verifier. Its purpose to ensure the freshness of the token to avoid replay attacks. Then this challenge is passed in to the attestation service. It collects all the other necessary data. They are putting in a key value pairs format in the token. There is a fixed set of data items which must be collected. This list of items is described in the PSA initial attestation API document. It's also include the challenge to the token, sign it with the key, and send it back to the non-secure side, and the non-secure side send over to the network to the validating entity. Originally, it was planned to use with asymmetric cryptography, and elliptic curve algorithm was chosen to sign the tokens. The reason was because the key size does matter. With RSA, the key size can be pretty big, but with elliptic curve algorithm, the key size is it's quite small. So you can put these keys to the one-time programmable memory to the device, which is usually quite expensive resource. Recently, a need was raised that asymmetric key-based cryptography doesn't really fit to ultra-constrained devices. And the idea come up that we should provide another way to authenticate the attestation token without using asymmetric cryptography. Next slide is about some internal structure of the initial attestation service. The right side is a secure word. It's provide an interface towards the secure partition manager. Has some dependency on the hardware. This is mainly to pick up some device-specific data and pick up the attestation key from the device. The core logic is responsible to collect all these data, form the packet. We are using QCBOR and tCozy libraries to encoding the data to the CBOR format and Cozy to sign the actual CBOR formatted token. And we have a glue layer, which is make possible to integrate with any cryptographic library. Okay, what is CBOR? CBOR is a binary data representation format. This is the intention was to use with constrained devices. So it's the result is a very short data format, much shorter than comparing to ASN1, for example. It supports many data types, integers, strings, time, and you can describe quite complex internal structures. You have maps, arrays, you can nested all of these. You can have an array, which is including a map, which is also including other arrays and so on. There are many open, this is standardized. There are many open source implementation for encoder and decoder. In TFM, we picked up this QCBOR library. So we are using that one to encode the CBOR format and to decode it. Encoding is used in the secure side, and the decoding is used in the non-secure side when the regression test suite is validating the token. But the decoder is not available in the secure side because it's unnecessary. On the right up corner, you can see a figure about the internal structure of the attestation token. These key value pairs are called claims in the attestation terminology. They are keys, and as I mentioned, we have a fixed set of data, so we have a fixed set of keys, and the values are corrected at runtime and encoded it in the token. By default, a CBOR object is not signed, so to ensuring the integrity and the authenticity and the confidentiality of a CBOR token, you need an additional layer, and this is called the cozy. Cozy is a way how to sign or encrypt a CBOR object. This is also standardized, and on the figure on the right side showing the internal structure. In the middle, I don't know, you can see my cursor moving?
Yes.
Yeah, so in the middle, there is the payload, which is the actual attestation token. So this payload, which is requested by the server, and the rest is just some wrapper around it, which is describing what kind of algorithm was used to sign the token. These protected headers is a mandatory field. Unprotected headers is an optional. Key ID can be a hint for the server which key you need to use for validating the token. And at the end of the token, the signature is also a mandatory field. For signing the tokens, we are using the T-Cozy library, which is also an open source implementation. Okay, now on the main topic of the today presentation, that actually what is symmetric key attestation and how it's different from the asymmetric key attestation. The main difference is that during the manufacturing process, not a symmetric key pair is generated. Instead, a symmetric key is provisioned to the device. In case of asymmetric cryptography, key pair is generated and the private part is provisioned to the device. Sorry, do you have a question?
Please, if you are not intending to ask a question, I would ask you to mute your Zoom. Yeah.
Okay.
Thank you.
So probably this was not a question. So the private part of the asymmetric key is provisioned to the device. It's unique, must be unique per device, and the public part is recorded in the database on the verification side. In case of symmetric, the same key goes to the device and goes to the database. Which algorithm is used with the symmetric key to generate the authentication tag? We picked up the HMAC creation because this is only relying on the hashing algorithm to create an authentication tag. The rest of the process, I mean the attestation, is more or less the same in both cases. Why we need symmetric key attestation? Because the asymmetric algorithm takes too much flash space, and ultra constrained devices don't have this size of flash available. So we try to come up with a solution which reduce the size of the secure processing environment, but still tries to keep the same level of service which is provided by the asymmetric crypto. TFM profile work is addressing this issue to make possible to configure TFM in a way that which results smaller binary sizes. Right now, the how to call standardization, not standardization, but the work on the profile small is ongoing. As part of this activity, this symmetric key attestation is developed. In the embed crypto, it's optional which algorithm to compile in. If you turn on all the asymmetric ones, then the size of the image is reduced significantly. HMAC-based authentication doesn't need asymmetric crypto. It's relying only on hashing algorithm. Okay, what are the drawbacks? So on the device side, you cannot really have too much drawback compared to the asymmetric crypto. You also need to be conscious when you are doing the provisioning of the keys, because both key, the private key and the symmetric key, is a sensitive data. So you are probably have the same policy how to do the provisioning of the keys to the device. But on the server side, you need to be more conscious when you are using symmetric key cryptography. Symmetric keys are considered as secrets, as assets. So you must be, or the verifier who is running the verifying service must be sure that those keys cannot be leaked. If the symmetric keys can be leaked from the database, then all the devices, all the corresponding devices are becoming untrusted. So in a centralized database, when you are stores asymmetric keys, it's to operating such a database in a safe and secure way to ensuring the integrity and the confidentiality of the database. The cost is much more and the complexity is much higher than in cases of asymmetric cryptography, when you have only public keys there, which is no secret at all. Here is a short comparison about the both way how to authenticate the attestation token. ECDSA is reflecting to the asymmetric KSB crypto, which is the original implementation and TFM, and the HMAC reflecting to the symmetric crypto. I try to collect the most important aspects, how to compare. As I mentioned, secret, the keys are the secrets, and in case of Symmetric, the secrets are stored on both sides, the device and in the database. So the database must be protected very well. For the requirements towards the database, in case of asymmetric crypto, you need to only ensure the integrity. So nobody is capable to inject an extra public key to that database, but the content not really a secret. In case of symmetric crypto, it's not true. Integrity is also still important, but you must to hide the database from the external world. Other important aspect is that who can verify the token, which is coming from the device. If you're using asymmetric crypto, then who is running the verification service, it can be anybody, it can be a third party, because you just passing the keys and the device corresponding data to that third party. These are not secrets, so that organization can execute that service. This, for example, could be a cloud service provider. In the opposite of the symmetric crypto, when the keys are secrets, so probably the device maker or the chip maker who has provisioned those secrets to the device must run by itself the service to not leak any secret to the outside world. On the positive side, for the HMAC, that it requires less flash space because it's relying only hashing algorithm and don't use asymmetric crypto. Okay, the same figure as before. What software components inside the attestation service will be affected due to this ongoing activity? The external interface, I mean, the PSA API doesn't change. The same function calls, get token size and get token will be available. Which algorithm to use during the runtime? It will be, so it's optional. You can choose by build time with the compile time switch. So at the same time, the device doesn't provide both operation parallel. You need to decide at the beginning. Inside the service, there is a small change in the hardware abstraction layer. That function which is picks up the key need to be fine-tuned. The T-cozy part need to add some more functionality because a new type of signature must be generated and added to the token. And also the crypto binding will get a new functionality to generate an HMAC token. But for the users from the non-secure side, nothing really changing. What is the difference in the token? On the left side, there is the old asymmetric crypto-based token, and on the right side, the new symmetric key distro. I highlighted the differences with this red color. So the first byte of a attestation token is called a CBOR tag. This CBOR tag is reflecting that what is inside the token. There is a CBOR tag for which is indicating that something is signed with cozy sign 1, and there is another which is indicating that is signed with cozy mag 0. So it's the first byte of the token. Then in the protected headers, you must specify which kind of algorithm used to generate the authentication tag. It's obviously changed between the two cases. I didn't highlighted the key ID as a changing part because it varies among devices. So it doesn't really matter here. The attestation token, the payload inside, it's not changed at all. It's the same in both cases. And also the signature is different because a different algorithm was used to sign the token. This is the last slide. I try to collect some resources about the attestation. The first three is some general resources. Where is the code? Where is the user integration guide and description about the API, which is very detailed, which data item must be included in the token, how the API looks like, and so on. And main resources, the last one, which is design proposals currently on review in the external, in the linear algorithm server. Feel free to read through those, comment, and ask questions regarding the implementation details. That's all from my side. So if you have any question, then please feel free to proceed.
Thank you, Tamas.
Tamas,
Yep.
may I ask a question? To use HMAC, is that supported algorithm in the spec, and does the attestation spec support more algorithm like CMAC or GMAC?
The current version of the official release version of the PSA attestation API, as far as I know, only supports this ECDSA signature. So this cause is signed one scheme, but it was agreed with the PSA community that in the new version, this HMAC will be added. But I haven't heard about further algorithms like CMAC or GMAC.
Okay, thank you.
As far as I know, the latest or the current PSA attestation API specification doesn't specify the algorithm used in course max 0 structure. Yeah, so according to the current specification and its reference, it seems that you can, in theory, use any algorithm supported in the course specification. Yeah, but as Thomas said, so maybe the later it will be specified by the PSA documentation. Yeah.
So basically, why we choose HMAC, it was an implementation details. Is it right, David?
Yeah, currently we select HMAC because it is, I think, the most simple scheme in the MAC algorithm or the AEAD algorithm. Yeah, but I think it's not an issue if it is switched to other algorithm for signature and verification. Yeah.
Yeah, I agree. Because I think if you don't do the encryption, then HMAC will be the best choice based on the power consumption and the speed because it just do the hash. So if you support both the encryption and the integrity check, then yeah, AED algorithm like GCM, it's much more suitable for this. So maybe if we have more encryption requirement on attestation, So maybe it will we can consider to use GMAC, for example. Yeah.
Yeah, it's good that you mentioned the power consumption, because it's also a difference between the symmetric and ECDSA and HMAC based attestation. So it use much less CPU cycles to generate the authentication tag. So if your device it's important to use less power, then also HMAC might be a better choice.
Yeah, and if it is required to, encrypt something confidential information in the token, so actually there is another structural encoding, especially for the encryption plus sign defined by the course. So I think if there is strong required for such use case, I think we can, raise the proposal to, raise the proposal and see if we can, have a further discussion. Yeah.
As far as I know, that currently there is no sensitive info in the token. That's why it's not encrypted by default.
Yeah. The token should be public by default. Yeah. Yes.
Yeah, I have a question. You already mentioned about power consumption, but what about performance? If you compare those two encodings, so is there any difference in the price?
Yes, so I haven't measured exactly, but computing an ECDSA signature takes much more times. I just have some rough ideas, 20 times, 30 times more than computing an HMAC tag.
Yeah, thank you. Just a reminder to everybody, so if you're more comfortable to use chat, please use chat. I will read your question.
So I have another question. Maybe it's not related to attestation design itself. It's just curious for the key provisioning. So, I don't know for the attestation key, is that recommended to derive the key from the root key of the device, or use different keys? For example, the keys which is provisioned by some specific identity.
Well, this is an implementation details, so there is no right answer for this question. I go back a few slides here. So you can have two options. So during the manufacturing process, if the device is capable to generating keys inside the device, then probably that's the best option. Whether is it deriving the key from the hardware unique key, or generating independently from the hardware unique key, the attestation key, I think it doesn't really matters. But what is matters that the key pair is only available in the device. So you cannot leak your private keys. But you need to know the corresponding public key to do the verification. For this reason, we have added an additional API call to the service. This is the last one with the yellow color. It's different so this is not an official API of the attestation service. You cannot find in the initial attestation API documentation. This is a TFM extension. And the purpose of this TFM extension is to retrieve the public key from the device. So if you generated the keeper inside the device, must have a way to know what is the public key. And the purpose of this API call is exactly this. There is another solution, possible solution, when you are generating the keepers outside of the device, and in the manufacturing floor, you are injecting the private part of the key to the device. This also could be a solution if your device is not capable to generate key inside. In this case, the public key is known because it's generated by a remote host machine or something like that. So it's not really need to use this get public key API. Does it answer your question?
Yeah, yes, thank you.
Any other questions? Okay, I understand that there is no more questions for the attestation.
One more comment from my side. So in case of symmetric key encryption, this API extension, get the public key, it won't be available because it's useless. There is no public key, so probably this API will just return with an error value or something like that.
Yeah, thank you, Tamas. And I see
Yeah,
public
that's
question.
yeah. So yeah, I can help to translate because it's mainly in Chinese. So it's but this question maybe not just about the attestation. It's about for TFM crypto service. Do we have plan to support Chinese crypto algorithm like SM series?
Is there any in the call who can answer this question? So I don't really know the answer.
Yeah, so I can probably jump in, Shibu here. I don't think there's nothing in the embed crypto roadmap. So just to be clear, the crypto service is not something that the TFM team is developing. We basically pick up the embed crypto project from the embed crypto repository and integrate that with the crypto service. So it's a totally different project. We are just a consumer of the embed crypto project, and I don't think there's anything in the roadmap for the Chinese algorithms, as far as I know. But it might be worth dropping a line to the embed crypto mailing list. So you can find the public mailing list if you go to trustedprovider.org. I think that would be a good channel to ask that question. But as far as I'm aware, there's nothing in the roadmap, at least in the foreseeable future, to support those algorithms.
Yeah, thank you, Shibu.
Actually, I want one extended question. So I think it is possible for the user to develop their own crypto services to support their own algorithms, I think.
Yeah, that's true. So TFM, as a reference implementation, we use embed crypto, but there might be another TFM user who don't want to use the embed crypto service, but maybe a more optimized crypto library that works better with that hardware platform. That's quite possible. Yeah.
Okay.
And again, if someone wants to add new algorithms, embed crypto is now a community project. Of course, we are looking forward to any external contribution. So the mailing list, as I said, is the best way to start that query and any further discussion.
Okay.
With the mailing list, it might be not so obvious to find it on the website, so you can, if you're interested, you can start from the TFM mailing list, which is well known. Okay. I understand that we have no more questions for the attestation. So thank you, Tamas. Thank you very much. I think this presentation will be available on the trusted firmware.org site in short time. And yeah, you mentioned, Tamas mentioned about profile walk and the symmetric algorithm new proposal. And David, who proposed? Sorry, I planned to switch the topic, but I see another statement in the chat, again in Chinese. Anybody can translate it? Somebody?
I think that's just the answer from David to the
Yeah,
original.
just
Ah, okay.
yeah, translate the answer to
Yeah,
Chinese.
thank you, David. Thank you, David. I didn't realize it was from you. Okay, so for the profile work, so we have a David who lead this profile work. He already proposed the document and it's under review now. So David, do you want to update us on?
Yeah, thank you. Thank you, Andrew. I just want to give a brief update on the current status of Profile Small. Yeah, we previously proposed Profile Small design document and the related patch set. So we received many helpful feedback and suggestions. So thank you, everybody. Yeah, and according to the suggestion and comments, we updated the design documents several times. And at the same time, we are connecting with developers and partners to collect detailed suggestions and comments on some very special features such as Cypher suits, the connectivities to clouds, and we want to enhance the description of the use case. So currently we are finalizing the feature lists and details. So I think we will publish a new version of the Profile Small proposal soon. So we can have a new round of discussion and review at that time. Yep. So Shabu, do you have anything to comment?
Yeah, I think you've covered it well. I think one of the questions when David presented the Profile Small proposal in the tech forum was what are the sort of use cases that Profile Small will satisfy, and I did indeed receive a lot of comments from some of the participants. So one of our major dilemma was should we include asymmetric crypto or not, so that it supports a full TLS with asymmetric cryptography and things like that. So the current thinking is we want to stick with just symmetric ciphers in Profile Small. Of course, it's just a reference profile. Of course, as a TFM users, you can of course reconfigure the embed crypto config file to add asymmetric crypto if your use case needs it. But at least from the project perspective, you'd still like to stick with symmetric because as we have plans to include asymmetric ciphers from Profile Medium. If you have asymmetric in the Profile Small itself, then the size difference isn't going to be huge. And the feedback so far is just with symmetric, there are going to be enough useful use cases for ultra constrained devices. So Profile Small from a use case perspective would be more for ultra constrained devices, which connects to a infra gateway sort of use cases. We have been checking with certain cloud providers whether they support connections with this symmetric ciphers, I mean PSK TLS. So looks like there are certain cloud providers whose IoT core supports PSK TLS. So Profile Small would allow users to either connect to a gateway which supports sort of PSK TLS or shared key mechanisms to connect, or to certain cloud providers. But of course, you can add asymmetric ciphers or move to profile medium if you want to connect to cloud providers who insist on asymmetric ciphers or a full TLS support. Yeah, so it's more aimed, profile small is aimed more towards gateway use cases. From a use case perspective, happy to hear any comments around that.
Yeah, and another big change is we renamed the profiles. Yeah, at very beginning we named them as profile 1, 2, 3. So after some internal and external discussion, we renamed them to profile small, media, and large to give a more explicit description on the purpose of the profiles, about the code size and performance. Yeah.
Yeah, and one of the feedback was to maybe name it to directly point at the use cases it covers, but then TFM just being the secure site component of a bigger stack, we were slightly hesitant to say call it profile gateway or anything, because then it all depends on what is there on the non-secure stack as well to firmly say it's a gateway use case. So I think in profile small documentation at some point we will maybe give example use cases for profile small. We can say, okay, it is intended for gateway connections or limited cloud connections, but didn't want to name the profile itself, because then it can create more confusion to someone who's looking at it, because TFM on its own can't do everything. It still needs a TLS stack and other things to satisfy those use cases. But we can add some wordings into the proposal to say what use cases are supported, but naming the current thinking as, yeah, as David says, just use small.
Yeah, right. Thank you, Shabu. Thank you, David, for the profile update. The document is under review. Please take a look and give more feedback, as you already did. And I want to remind that another document was recently got a new version. It's a project maintenance proposal for TFA and TFM. This is combined proposal. So welcome to review, and again, give any feedback what you think is meaningful. This is the proposal to how to maintain your platform and how to contribute to the project, TFM and TFA. I think the platform owners might be interested to take a look. That's basically all what we planned for today, and this is the good occasion, and we have like 10 to 11 minutes, so we can discuss any topics what was raised on the mailing list, TFM mailing list. A quite big discussion and interesting discussion was about performance improvement and how improve the time for changing secure to non-secure site and interrupt calls. It was mostly initiated by Eric from TI, and Alan participated, contributed there, but I think they are not on the call today. So, anybody else wants to discuss this or any other topic? As this forum is a great occasion for a quick discussion, for not face-to-face, but do not wait for your response if you send it over the mailing list. If nothing, so let me close this session for today. Thanks, everybody. Thanks, Tamas, for presenting. And have a good day, and see you next time in 2 weeks. Goodbye.
Thank you.
Thanks. Bye bye.
Thank
Thank
you.
you.
Thank you.
Bye.
Bye bye.
Bye bye.
Bye bye. Thank you.